Hey everybody, it's John here. We're going to solve this trig equation. Now, this is telling us to find all of the solutions. Now remember that sine, cosine, all of these functions are cyclic functions, meaning that the y values repeat over set intervals. And so there are infinitely many solutions to many of these equations. So if I'm going to write all of the solutions, I'm going to have to do that in a way that considers all solutions. So we're going to do that now. Okay. So what I'm going to do first is I can't solve this equation with this sine of 3 theta if I have a sine of theta here. And so I'm going to try to reduce sine of 3 theta to be sine of some other version of theta. Well, luckily, earlier in this lecture, in a previous video, we proved that sine of 3x is equal to 3 sine of x minus 4 sine cubed of x. And so that means I can rewrite 2 sine theta minus sine cubed can be written as 3 sine theta minus 4 sine cubed theta. Notice how I put this in parentheses because we're subtracting. And so the negative is actually gonna distribute here. Now we're finding all of the solutions here, but we're just finding it over the interval from 0 to 2 pi. But I'm going to show you what that looks like in the next lecture. So next week we'll talk about what if we wanted to find all of the solutions. Today we're just finding it from 0 to 2 pi, and so there's a finite number of solutions, but in the future there might be infinitely many, and we have to talk about how we're going to write those infinitely many solutions. So let's distribute this negative sign. So we have 2 sine theta minus 3 sine theta plus 4 sine cubed theta. And this is equal to 0, and this is equal to 0 because this is an equation. So 2 sine theta minus 3 sine theta, I have 2 of something, and then I have 3 of the same something. So that's negative sine of theta. And I have this 4 sine cubed theta. I'm going to write that out in front because it's going to make this easier to solve. Notice I have a sine theta in both terms, so I can factor that out. I have a sine theta that I can factor out. That leaves me with 4 sine squared theta minus 1 equals 0. And this right here, this expression right here, this looks like the difference of 2 squares. I have 4x squared minus 1. Think of it as 4x squared minus 1. 4x squared minus 1 factors 2x plus 1, 2x minus 1. So 4 sine squared theta should factor 2 sine theta plus 1, 2 sine theta minus 1. And we still have this sine theta out in front. And this is all equal to 0. And since we're multiplying 3 things together and we're getting 0, the 0 product property is at play here. So that means that sine of theta equals 0, which definitely means theta equals 0. It also means that theta equals pi, And theta would equal 2 pi as well, but we're not including 2 pi. We are excluding 2 pi because of the parentheses up there. So we have two solutions here. We also have 2 sine theta plus 1 equals 0. So that means that sine theta equals negative 1/2. Now, where does sine of theta equal negative 1/2? Well, if I know my unit circle correctly, going from 0 to 2 pi, not going backwards, because negative angles are not on this interval. So using what I know about the unit circle, I know that this happens at 7 pi over 6, which is pi over 6 past pi. So that's the first time that sine of theta is negative. And then it also happens pi over 6 short of 2 pi, which is 11 pi over 6. And then we also have that 2 sine theta minus 1 equals 0, which means that sine of theta equals positive 1/2. And this happens when theta equals pi over 6 and when theta equals 5 pi over 6. So pi over 6 is that smaller angle, so I'm not as far up. So 1/2, I'm not as far up. And that happens again in the second quadrant, pi over 6 above pi. So pi over 6 short of pi, which is 5 pi over 6. Now this angle, the angle at which sine equals 1/2, this is going to come up a lot. So it's good to just know these angles. So if I want to write my solution set, what I'm going to say is I'm going to write the solution set as a set. And I'm going to start with the smallest value, and I'm just going to write all the values in increasing order. So this would be the best way to write your solution set so you don't have to keep writing theta equals 0, theta equals pi, theta equals 7 pi over 6, theta equals... You can just write them all. Theta equals this. This is my solution set. So I hope that made sense. We used some factoring. We used sort of our power reducing formulas, or our double angle formula, and then our sum formula is what we used. Not the power reducing. We're going to use that. We're going to use the double angle formula on the next one. And let's go to the next example. So here we have, again, we're finding all the solutions from 0 to 2 pi, including 0 but not including 2 pi, for sine of x minus cosine of x over 2. Now our first thought is probably going to be, should we use the half angle formula on cosine of x over 2 to bring it in line with this x here, which is a really good thought, but it just doesn't work. And so instead what I'm going to do is I'm going to use the double angle formula for sine to rewrite sine of x as 2 sine of x over 2 cosine of x over 2. So that everything has x over 2 inside of it. And that's the easier way. The reason I'm not going to use the half angle formula is because the half angle formula has the half angle formula has a square root in it, which makes it much more difficult to work with. So we don't want to introduce a square root in the middle of this equation. So instead, I'm going to think of sine of 2 theta. We're going to let theta equal x over 2, right, is equal to 2 sine theta cosine theta. So if theta is x over 2, when I plug x over 2 into here, I just get x, because x over 2 times 2 is x. So sine of x becomes sine of x over 2 cosine of x over 2, with a 2 out in front of that, minus cosine of x over 2 equals 0. Now the benefit of that is now I have a common factor in both terms, and now I can factor. And factoring is always my favorite way to solve any equation. So I'm going to factor out a cosine of x over 2, and I'm left with 2 sine of x over 2 minus 1 equals 0. So I'm looking for when cosine of x over 2 equals 0, and I'm looking for when sine of x over 2 equals 1/2. Like I said, this is going to come up a lot. So when does cosine normally equal 0? Well, cosine normally equals 0 at pi over 2, and it'll equal 0 at 3 pi over 2. So those are the two places where cosine is normally equal to 0. It's pi over 2 and then 3 pi over 2 on the unit circle, right? But it's not, the angle isn't theta. It's not theta is equal to pi over 2. It's x over 2 has to equal pi over 2. And so when I set this equal and I solve for x, the 2's cancel. And so here I get that x equals pi. Here I get that x equals 3 pi. And 3 pi is not on the interval that I'm talking about, so this is not a solution. It's just this one. So now let's figure out where sine equals 1/2. Sine equals 1/2 at pi over 6 and 5 pi over 6. But again, it's not theta that's equal to pi over 6. It's not x that's equal to pi over 6. It's x over 2 that's equal to pi over 6, because that's what's inside of here. I'm looking for when the inside of sine would equal 1/2. That's going to happen when the inside of this function is equal to pi over 6 or 5 pi over 6, but the inside is x over 2. So if I multiply by 2 on both sides, here I get x equals pi over 3, and here I get x equals 5 pi over 3. And those are both in the interval from 0 to 2 pi. So I'm going to take both of those. And so I'm going to write my solution set. My solution set is that x equals, starting with the smallest value, pi over 3, then pi, and then 5 pi over 3. These are the solutions to my equation. Now next time, again, we'll talk about how we can find all of the solutions, all of the infinitely many solutions. If we weren't specified an interval, we were just asked to find all the solutions. We're going to go through that next time. But for now, practice the problem set and reach out to me if you have any questions, please. All right, I will see you next week.